Hi there, I'm John Michael with GMAT Ninjas, and welcome to the Rates 1 video with conversions. Putting two topics together because they might not really be two topics. They might just be one big idea. What is a conversion but a kind of rate? But then again, what is a rate but a kind of ratio? Ratios are fractions, fractions are percents, percents are decimals. It's like there's just one big math idea. And if we had it, we'd have it all. Is this video for you? If you are in any way unfamiliar with the distance equation, you should probably pause. You could even close the tab, head off, study up, get yourself clear on this kind of a formula, variations on it, ratios, fractions. Come on back, we'll be here. If you've got that math knowledge, maybe you're having a bit of difficulty adapting it to quant problem solving on the GMAT, this video is for you. If you've been working on your quant and you just can't seem to quite hit your target score, there might be something for you here as well. We're going to start pretty simple. It should be pretty difficult by the time we're done. So those of you who might be on a plateau looking to make another jump, there may be some things for you at the end. Hopefully there's some things for you throughout. And yes, we'll have a little bit of data sufficiency here. Obviously, it is no longer part of the quant section. It's in data insights, but it is a math-based question type most of the time. So we want to be able to use these math concepts, not just in quant, but in DS as well. And that's about it. Let's get to it. Treat yourself to a breath. Grab hold of your yellow pad, your whiteboard, and your marker. I mean, you could work with paper and pencil or pen and paper, but you know that on test day you won't be allowed to. So you might want to make your practice as much like test day as possible. I'm just saying. In any event, whatever you've got to work with, take that breath. Here comes the question. 2 minutes is your target time, and we'll be back on the other side of 2 minutes. Off you go.
Hey everybody, Charles here. Sorry for the interruption. Before we get you back to that quant content, 3 quick things I'd love for you to be aware of. First of all, this video is part of our full, free, complete GMAT course that's available up on our YouTube channel. If this course is saving you money that you would otherwise spend on a course or a tutor, please consider donating some of that savings to charity, either a charity that you love. If you don't have a charity that you love, we've got a list of charities that we love to support on our website, gmatninja.com. Second thing, if you love that presenter that you're watching in this video, not me, the other one, they offer one-on-one tutoring. If you're interested in that, gmatninja.com and we can set you up. Third thing, finally, If you're doing great on the GMAT, doing great on the GRE, starting to look for admissions help with your applications for grad school, we would love to refer you to a bunch of our favorite companies. So just hit us up. There is a contact form on our website, gmatninja.com. Also, a link in the video description. Just fill that out. We'll send you a list of our favorite admissions consultants, not just at our company, no strings attached, not going to sell your email, not going to try to sell you anything. We just want to make sure if you've put in the hard work on the GMAT, that you end up in the best possible hands if you need help with your applications. All right, that's it. Enjoy the quant.
Okay, that is 2 minutes. If you are still working, entirely fine. Press pause and resume when you have an answer. If you are ready to talk about this question, let's talk about this question. So, first thing I do, I read the question. Second thing I do, I read the question again. Every quant question you meet on the GMAT is worth reading twice. Make that part of your practice. If it's a short, simple question, then it costs you nothing to read it twice. If it's a long and complicated question and you have a feeling that you don't really have the time to spend reading a long question like that, then you really need to read that question twice. If it's long and complicated, it has lots of parts and pieces. You want to be sure you haven't missed anything. You're solving the question they're asking and nothing else. First time through, I read without writing anything down. I'm getting a sense of the question. The situation here, okay, she starts with some money, she's making some changes, she ends up with other money. Great. Second time through, I start looking at the numbers, grabbing hold of my specific details. And I like to make a note of what it is I'm being sent in search of. And we're looking for the number of Icelandic krona that Stefania is going to get for her 200 Polish zloty. And, well, then I get to work. She's got to do 2 exchanges. It tells us so in the question. We've got some rates here. She's going to turn her zloty into Norwegian krona. She's going to turn her new Norwegian krona into Icelandic krona. I do some math. I do some more math. I have an answer. Why not? And when I'm working on a word problem, I really like to follow the narrative that can really keep things clear. What's the starting situation? What happens next? What happens next? Where do we end up? And there's my answer. But after reading the question twice, my next move is to pause a moment and pick my path. How do I want to proceed? How am I going to turn what they've given me into the thing they're asking for? And if we take a moment to reflect, well, we notice that this Norwegian currency exchange is expressing everything, not just in terms of Norwegian krona, but in terms of 100 Norwegian krona. So if these 2 things are equal to the same thing, then we can say that 36 zloty are equal to 1260 Icelandic krona. And now where we begin and where we want to end are in a direct relationship with each other. Okay, so there's our rate. And the rate is constant, whether we are going to change a few zloty or a lot of them, the rate's going to be constant, so we have a proportion. It's 200 zloty that she wants to exchange, and we don't know how many Icelandic krona she's going to get. Marvelous. I have a proportion, I have 3 numbers, I have 1 unknown. This is a thing I can solve for. And maybe I go ahead and cross multiply. Maybe I do a bit of division to isolate my unknown. Again, pausing, thinking. I can see that there are patterns in the numbers here. As I said from the beginning, we want to look for relationships between numbers. I can recognize the square of 6, and I can recognize that I've got a 12, and I've got a 6 in this number. If I factor out a 6, maybe it's a little bit simpler, and the sooner it's simpler, the happier I'm going to be. So take 6 out of 36, and 6 out of 12 is 2, 6 out of 6 is 1, and I've got my 0 there. Nice. But I recognize the number 21. That's a multiple of 3, and I have an even number here. So this is a multiple of 3 and 2, which means it's a multiple of 6. Let me do that one more time. 6 out of 6 is 1. And how many times does 6 go into 210? Well, 6 into 21 would be 3. That's going to be 180. 30 left over. That's 35. So the real ratio, the real rate of exchange, is that every 1 Polish zloty gets you 35 Icelandic krona. And how many are we changing? We're changing 200. We can do a cross multiplication. X times 1 equals 200 times 35. That gets us right where we want to be. And we can also sort of see when we've got a very straightforward number in a proportion, what turns 1 into 200? Well, multiplication by 200. So what would we do to the corresponding number to get the corresponding result? Also a multiplication by 200. Many paths to a correct answer. If you jumped on this and changed to Norwegian krona and then changed that to Icelandic krona, you've probably gotten to the correct answer. Was there another way to get there? Was there a better way to get there? There's not necessarily one best way. If you see a path that you can take that gets you to a correct answer in 2 minutes or less, it's a good path. Nevertheless, even when we get a question right, it can be useful to review our work and say, okay, that did the job. Is there something else that makes sense to me? Something else that's more efficient? Something that I might have missed that could have saved me a bit of work later on, would have gotten me onto the next question that much sooner. Let go of Stefania and her travels. Here comes another question. I'll see you on the other side of 2 minutes. Okay, that's 2 minutes. As always, if you are working, you can press pause. If you're ready to talk, let's talk. Read the question once. Pretty short. I read it again. First time through, okay, we've got miles per hour and we're looking for inches. We've got a speed, okay, and read a second time. We've got some specifics here. Okay. What are we looking for? We are looking for inches in 1 second. Okay. There are always multiple paths to a correct answer. There are a bunch of things we can do here. We can move one piece, the other piece, move our miles, move our hours. Let me offer you a way to approach a question like this. I think about what I'm starting with, and what I'm being given to work on is seconds. One in particular, but right now I'm just thinking in terms of units. And what do I want to end up with? Well, I want to end up with inches. So how am I going to get from seconds to inches? Well, when we have rates, when we have a relationship between actual things in the real world that we express with the fraction bar, we can cancel units in the same way that we cancel numbers to simplify. So I don't want an answer in seconds. I need some kind of a rate that puts seconds in the denominator. What are seconds in a relationship with? Well, it doesn't say so, but we know that seconds are in a relationship with minutes. If we do that multiplication, we can cancel our seconds, but we'll have an answer in minutes. We don't really want that either. What's another conversion that will let us cancel out minutes? Well, minutes are in a relationship with hours. Still not what we want. What's in a relationship with hours? Now we've got the given rate. Miles are in a relationship with hours, but we still aren't where we want to be. We want to get to inches. Miles, however, are in a relationship with yards. Yards are in a relationship with feet, and feet are in a relationship with inches. If we do this 7-part multiplication, our units will cancel, and having started with seconds, we will wind up with inches. Now it's time to put the numbers in. And this is the part where we've got to pay some attention. We've got to make sure to put numbers in the right place. How many seconds are we starting with? Just one. Relationship of minutes to seconds, it's 60 seconds in every 1 minute, 60 minutes in every 1 hour, and 10 miles every 1 hour. Miles to yards, they're giving us here 1 mile. I'm going to try to fit this number in, 1760. Feet to yards, 3 feet, 1 yard, 12 inches, 1 foot. And sometimes we will find ourselves flipping over rates that are given to us. Let this logic tell you where the units belong, and then pay attention to fit the units in as appropriate. So we can kind of let go of our units now and give some attention to these numbers. I'm going to tell you one thing we're not going to do is multiply straight across the top, multiply straight across the bottom. Let's make things simpler sooner. Let's do our cancellations. What have we got here? Some of the easiest things that jump out, we have 10 miles per hour. 10 cancels with 60 to give us 6. That's off to a pretty good start. We can even take another 10 out of these, and that's going to make our lives a bit easier. And what have we got? I see 6 and 12. That will turn my 12 into a 2. And actually, while I'm looking at this end, I've got 2 and 3 canceling my other 6. All of this has melted away, except the number 176. So apparently, when we start at 1 second and all of these things happen, we're going to cover 176 inches, which is an option over here. Again, we can do it bit by bit. I really like to set up a long chain like this, know what I'm starting with, know what I want to end with, and insert your conversions all along the way. Start with them blank, unit to unit, fill in the numbers as appropriate, do all the cancellation you can early on, do as little multiplication as possible. Happy day. Take a breath. Here's another. Okay, that is 2 minutes. You can pause or talk, your call. I read this question once. Okay, she's running a set distance at 2 different speeds. Okay, I read it a second time. What specific numbers are we talking about? What are the speeds, the distance? Got all of that. I want to stop and see what it is I'm being asked for. And we are looking for her finish time. Okay. What can I do with what I have to find the time she finishes? Lots of options, lots of possibilities. Me personally, I'm going to draw a picture. And boy, it's not going to be a very interesting picture, but I really want to see that. This whole distance is 6 miles. And what's she do? She starts out and she does a bit of a jog, and then she goes to a run. And there are some things we know, and some things we don't. Thinking in terms of our beloved dirt equation there, things we do know, things we don't. Over here, we know that she's going not 40 miles an hour. That is awfully fast. Pamela has rockets in her boots. She's moving at 4 miles per hour. You're allowed to make mistakes if you catch them. Better not to make them in the first place, but come on, it happens. Her rate here, 4 miles per hour. Her rate when she runs, twice that. Okay, fine. If you don't want to say the number 8, we'll say it for ourselves. Time, 20 minutes. Time unknown, distance as yet unknown. We want her finish time, so I think what's going to be key here is finding her run time. When we know that, we'll know how long it takes, relate that back to the clock, and we'll be happy people. So when we're looking for time, we start with the basic form here, and of course we can rearrange the terms to find any one. If we want to find time, we've got rate, super. We'd like to know distance. We don't have it, but we can find distance here pretty easily. When it comes to jogging, she is traveling at 4 miles per hour for a time of 20. So she goes 80 miles, right? No, of course not. We're keeping track of our units. They make all the difference. We're measuring her speed in miles per hour, so we want to think about how many hours she travels. 20 minutes, 1/3 of an hour. Units cancel. Hours and hours will go away. We'll be left with miles, and we have 4/3 of a mile. A little unusual, not super crazy. We could leave it as an improper fraction. Might be a little bit easier to think in terms of 1 and 1/3 miles. Okay, then what remains on the other side? We can do this subtraction, and remaining over here is 4 2/3 miles. Super. We can now solve for time, no problem. What is our distance? That's our numerator, 4 2/3 miles. What is our denominator? 8 miles per hour. So I'm going to do 2 things to make this manageable. I'm going to get this back into an improper fraction. 4 is 12/3. 2 more thirds makes this 14/3 miles. A little strange, but not the end of the world. And division by a number is multiplication by its reciprocal. So division by 8 is multiplication by 1/8. As that number flips, our units are going to flip as well. 1 hour corresponds to 8 miles. I want to simplify sooner than later. I can take out a 2 from both of these even numbers. That will leave me a 7 up top and a 4 down below. Now I multiply straight across, and I've got 7/12 hours. We can either stop and think about it, think about a clock face. Every 12th is 5 minutes. We could actually set up a multiplication. 7/12ths of an hour at a rate of 60 minutes for every 1 hour, because we're doing rates and conversions, right? 12 goes into 65 times. However we want to get there, we are talking about 35 minutes. And she started at 9, and we see she spends 35 minutes running. This is her run time. Her total time is, of course, those 35 minutes plus the 20 minutes she spent jogging, and our correct answer is C. Go back to the question, check in with what you were sent in search of before you actually select your answer. When does she finish? We have found her run time. That's not her finish time. But you didn't fall for that. Nah. Okay. How about we do another? Yeah, why not? Here comes another. Okay, that's 2 minutes. Pause or talk. Suit yourself. My first read, I've got a sort of curious situation. So many parts of the world, so proud of their mosquitoes. Wish I had some more details here. I don't. That's okay. Jeremiah swatting mosquitoes. He falls short. He needs to make it up. Okay, fine. No problem. Coming back for the details, I've got a bunch of numbers. What am I here for? I want his average mosquitoes per day for the last 5 days. Feels kind of complicated. Feels like there's a lot packed into these words. An average, a low average, a higher average. There are a lot of ways we can come at this. You'll be surprised to hear, I'm sure. There are a bunch of things going on. If it's a path that gets you to a correct answer in 2 minutes or less, it's a good path. Here's how I think about it. Jeremiah's plan was to swat 20 mosquitoes per day for 7 days. That means that by the end of the week, he was going to swat 140 mosquitoes. And if he swatted them all on the first day and didn't swat any for the next 6, well, that would still be 140 over 7, 20 a day. He could swat exactly 20 every day. That would be 20 a day. It doesn't matter how he gets there. If he swats 140 mosquitoes, he will meet his goal. Okay, so how near or far is he from his goal? He's had 2 days in which he has swatted just 15 mosquitoes per day. That means in those first 2 days, he has swatted 30 mosquitoes. So in order to get where he wants to be, in order to reach his target, he's got to get 111 mosquitoes in the next 5 days. That will give us his R rate of mosquitoes per day. Solve for R by isolating it, by dividing both sides by 5, and we've got 22. Is this a rates question? Is this a statistics question? Yes. Sure. Why not? Rates are ratios, ratios are fractions, fractions are percents, and all the rest of it. There are a lot of ideas that overlap, designating a question as belonging in this group or that group. Who's to say? As you read these questions, the GMAT is really good at putting multiple concepts into a single question. They're really good at writing questions that look like one thing and are another. Be like water, my friend. Adapt yourself to the question you're looking at. Give it what it needs. Nothing less, nothing more. Certainly, there are other paths that will get you to this correct answer. That's how I think about it. Next up is data sufficiency. Take a breath. Remind yourself how data sufficiency works. We've got a question. We've got statements. Think about how you approach it. Treat yourself to a breath. Grab hold of your pen. 2 minutes is still your target time. Give it your best shot. Okay, that's 2 minutes. Pause, or let's talk. Data sufficiency. Thinking about it, working with it. Read the question, get a hold of it. I want to gather my given information, and we're actually told a lot of things. Anne's time is 2 hours. Elizabeth's time is 3 hours. And yeah, so, and I might just draw myself a little picture. There's the whole marathon, and at some point, Anne stopped and Elizabeth started, just to represent that to myself, to make sure I've got a grasp of the situation. That's about all we have, all this constant pace, fine, thank you. Not that we take it for granted. Data insights will mess with you, and be careful of making any kinds of assumptions. If it's constant, we want them to tell us that it's constant, or an average speed over time, or something like that. The new data insights will sometimes get a little funny about things like, ooh, stopping and starting, speeding up and slowing down. Take them at their word. Okay, and the question we are here for is Anne's finishing time, total time. What's that going to equal? I like to write my question mark with my data sufficiency questions. This is a thing I don't know. This is a thing I am looking for. Sometimes if I leave the question mark out, I can think that I'm giving myself a fact here. This is the unknown, her total time. And then I want to push the question a little bit. Always happy to write a simple formula to keep it straight in my mind. So time, which we're looking for, would be distance divided by rate. So distance is given, 26.2 miles. So if I knew Anne's rate, that would work as well. That would let me calculate her total time. And actually, another way to get her rate, I've been given the time she takes on her turn, her first leg. If I knew the distance of her first leg, that would also give it to me. So Anne distance. If I can find these things one way or another, I can work my way back to her total time. Push the question. Think about paths that would get you to the answer. I've been talking a lot about multiple paths. Yeah, in this case, I want to keep my options open. Anything that will get me to the thing I'm looking for is good to go. And I pop my little grid over here on my top right corner. I draw myself a gigantic capital T, and I go to work on the first statement. Elizabeth's distance is 3 times Anne's distance. I could start thinking about writing some equations or that sort of a thing. I just want to pause and consider what that actually means. If this is the whole marathon, then the Anne segment, the Elizabeth segment is 3 of those. So we can think of this as all of Elizabeth, or we can think of that as 3 Annes. Well, what does that tell me? That tells me that Anne ran 1/4 of the whole marathon. So Anne's distance is the full length of a marathon over 4. I'm done. Anne's distance is a knowable thing. Put it in relationship with her time, and we have her rate. Apply her rate to the full distance, and we will know her finish time. This is a sufficient statement. Eliminate 3 of our possible answer choices. Continue on to the second statement. Elizabeth ran twice as fast as Anne did. Elizabeth's rate is twice Anne's rate. This feels like we know a lot less. Are we ready to call it insufficient? Let's push on it a little bit harder. We know that if we want to talk about rates, we're talking about distance with respect to time. And what we do know, they're times, so that gets us a little bit closer. Elizabeth distance over 3 is 2 times Anne distance over 2. 2's cancel, multiply both sides by 3, and we see that Elizabeth's distance is 3 times Anne's distance, and it's telling us what we got from the first statement. And we know that's sufficient. We have 2 sufficient statements. Often in data sufficiency, we'll get two statements that look almost alike, but are slightly different. We handle the first one, and we think that little differences, it'll often make a big difference to the outcome. So we might be on our toes. These are sort of similar, but profoundly different. They actually do get us to the same place. We have two sufficient statements, different ways we can think about this, different ways we can set up that last one in particular. But that'll do. Okay, last question of the set. Get yourself ready. Here it comes.
All right, two last things. Thank you so much for making it to the end of the video. If you've made it this far, you're one of those awesome people that's obviously really engaged in this GMAT thing. We would love your comments and your feedback. If there's anything else you'd love to see in our videos, hit us up in the comments. We'll do our best to oblige. Second thing, if you're enjoying it, hit that like button, hit the subscribe button. Helps other test takers like you find our full free video course. You need anything else? You know where to find us, gmatninja.com. Thanks so much. Enjoy this last question.
Okay, that's 2 minutes. You can pause or we can talk. Give this question a read. Doesn't seem too strange. We've got someone driving two different speeds. It's a little bit like Jeremiah falling behind with his mosquito swatting and then catching up. Okay. We have an x, which is a little bit different, but okay. Nothing here seems too strange. Average, total average speed in terms of x. Okay. There are plenty of ways to come at a question like this. I'm going to talk about it. There are shortcuts, there are techniques, there are all sorts of things, but if we don't have a solid grounding in the math of it, sometimes the shortcuts can make more trouble than doing things the long way. So let's have a look, let's have a think. When we're in search of total average speed for a total journey, we know that we must have total distance over total time. And that comes up, obviously, as soon as you meet this concept. If you go uphill at 40 miles per hour and you come downhill at 60, the average is not 50. You know that. So we need to find our total distance. We need to find our total time. Thinking about what we have to work with, I want to think about the first part of the journey at 30 miles per hour. I'm going to write that in lowercase. And then there's another part of the journey that happens at a faster speed. I'm going to write that in big letters. So our total distance is the two distances, and our total time is the two times. Let's start putting in what we know. The thing that is most certain is that we absolutely have the rate here, and we have some kind of information about the distance. It is x% of some total distance. Time as yet unknown. Over here, again, we know our rate, 70 miles per hour, and our distance, we can consider that whatever didn't get done at 30 is getting done at 70. So that's 100, let me give myself space. That's the rest of the percentage, 100 minus x over 100, multiplied by that total distance, and some time we don't yet know. Okay, so things are sort of taking shape. We might be able to find our denominator here. Let's isolate t. And I'm going to write that as a multiplication by its reciprocal rather than writing that as a division. And over here, same thing, 1 over 70 multiplied by 100 minus x. That is a term, a quantity, distance over 100. That's our other time. We can add these two together, and that will give us the denominator of the thing that we're looking for. How to find our little d and our big D, we don't need to, because we've sort of invented the term dist, which is our total distance. So that's our numerator. Now I've got a monstrous fraction. Over here, little t is x times dist over 30 times 100. I want to make sure I get the right number of zeros there. And I'm going to add to it capital T time. Multiplication by 1 doesn't do anything. And across the bottom, I again want to make sure that I have the right number of zeros. So my x is in here, that's okay. X is in the answer choices, but I've got this dist here, my unknown distance, and it's in every term. So I can factor it out of these two terms. It will then cancel top and bottom, and it's like it was never there. Our numerator becomes 1, and our dist is now gone. So this is x over 3,000 plus 100 minus x over 7,000. Okay. This looks just about doable. I want to add these two terms. Common denominator is going to be 21,000. So keep my 1 up top. This term, I'm going to multiply by 7 over 7. That's going to give me 7x over 21,000. And over here, I'm going to multiply by 3 over 3. That's going outside my parentheses. I'm going to go ahead and write this one little step at a time, just to be absolutely certain. Sometimes I take 2 steps at once, but sometimes taking 2 steps at once gets me into trouble. So I'm going to move over here where I have a bit of space. Still, I have a 1 up there in the numerator. And now I'm going to go ahead and combine things down here. Denominator 21,000. What have I got? I've got 7x. Distribute that 3 plus 300. Watch the subtraction, minus 3x. Combine like terms. Still, I have 1 in the numerator. 4x plus 300 over 21,000. And of course, division by this crazy term is multiplication by its reciprocal. And its reciprocal is waiting for us over here. I mean, we're happy people. We're not unhappy people, but that's a lot of work. That's a lot to get done in 2 minutes. Are there savings to be made along the way? When we're at this point in the process, we might notice that we're taking these percentages of distance. And if we think with our human brains, well, it doesn't tell us how far apart these 2 places are. By the time we're finished with the question, we still don't know how far apart these 2 places are. Maybe they're very close, maybe they're very far apart. That seems not to matter. So if total distance can be anything, then we can choose what we want to make it. And if we're doing this multiplication by percents, it might be convenient to just decide that total distance is 100. If we do that, we can cancel these percentages out. And then the next line in our work is going to be that t equals x over 30, and big T is over 70. And things feel a bit more manageable. We're going to want to remember that our dist is 100 when we add these two things together down in the denominator, but that kind of smooths our workings out. That's pretty handy. But now we're kind of realizing there's a lot we don't know. We never knew the distance, didn't know it at the beginning, didn't know it at the end. We don't know x. We don't know x at the beginning. We don't know x at the end either. So maybe we can assign a value to x. If we choose some number that represents how much of the time Pablo drives at 30 miles an hour, maybe we can work our way to an answer without doing quite so much of all of that manipulation. And a really nice, easy number, they don't say we can't. What if x is 0? And whenever I make up a number like that, I put a box around it that is a reminder to myself that's not a real thing, it's a thing you made up. If x is 0, then Pablo spent no time, no distance driving 30 miles an hour. So obviously, if he only drove 70 miles per hour, his average speed is then 70. When x is 0, we should get 70 from the correct answer. Drop it in here, that gives us 140, that has to be wrong. Drop in 0 here, that gives us something a little bigger than 20, that has to be wrong. Drop in 0 here, and no, we get 70. That's interesting. If x is 0, we then have 350 over 5, we have 70. So, oh, that's a happy correct answer. That is not a happy correct answer. If you employ this kind of technique, you've got to test each of the answer choices. We're seeing right here, we just got a false positive. We know that's not the answer, but we wouldn't know that if we hadn't done the work the long way. So we've got a happy answer there. This over here, if that's a 0, we're going to have something pretty odd, definitely not 70. That's going to be out. And of course, if this becomes 0, then we've got 20,000 divided by 300. That also gives us 70. So we've got 2 contenders, okay? So we're not done. We need to try again. We're going to be super smart. We'll do the other thing. Let's say x is 100. He only drives 30 miles per hour. He never speeds up to 7. Well, that makes it really easy. His average speed is 30. When x is 100, the result should be 30. Put that in up here, and it still works. 2 times 100, 350 minus 200, 150 divided by 5 gives us that 30. This answer choice is still happy, and we know that this one will work as well. These techniques are great. They're not the be-all and the end-all. We can, however, use this technique to get us to a correct answer. Let's suppose that, our distance is 100 miles and x is 30. Made these two numbers up, so that means he drives 30 miles at 30 miles an hour and 70 miles at 70 miles an hour. Well, of course, that takes 1 hour and 1 hour. Total distance, 100 miles. Total time, 2 hours. Average speed, 50 miles per hour. Now we've got something. When x is 30, the result should be 50. Put that 30 in up here, and we will see that that does not give us the 50 we want. Not too far off, but it's definitely wrong. Put in 30 down here, and we will see that we have got a correct answer. Might take a moment to do some of these calculations. That does give us a correct answer. And of course, that's the question. This kind of picking numbers can save us from a lot of drawn out algebra. It still takes time. And if we are too clever for our own good in picking, numbers like 0 and numbers like 100, we have a good shot at getting this question wrong, even though we're being clever and taking a shortcut. This is the best way to go if we're going to take a pick numbers approach. Is that the right way to answer this question? Don't know. You've probably thought of something I haven't even thought of. If you have, put it in the comments. Tell me about it. I would love to learn yet another way to tackle this question. Okay, a little bit of a monster. Wacky looking result. We're all happy people. Rates. Hope you've gotten something out of this. In the comments, let me know all of the ways I didn't think to get to answers to these questions. Let me know what worked. Let me know what you have questions about. And off you go. Happy studying.